Welcome. My name is MD Mahmudul Hassan, Assistant Professor at Department of Geoinformation Science and Earth Observation, Patuakhali Science and Technology University, Bangladesh. After this video, you will be able to learn the role of a spatial decision support system and planning support system in urban plan. A spatial decision support system. Decision support systems were developed as a response to the shortcomings of the management information system of the late 1960s and early 1970s. At this time, MIS did not adequately support analytical modeling capabilities or facilitate the decision makers' interaction with the solution process. DSS provide a framework for integrating database management system, analytical model, and graphics in order to improve decision-making process. They are designed to deal with semi-structured problems which are poorly defined and partially qualitative in nature. The decision support system concept was extended to the spatial content in the development of SDSS. The architecture of SDSS helped decision makers to make decisions on different locational alternatives. GIS have been used to generate and more spatial data which were then used as inputs for the analytical models. Results of the analytical model were displayed by GIS. More recently, advances have been made in incorporating analytical models into GIS. For example, location allocation and spatial interaction models have been incorporated as a standard function of ARC or INFO. It is to be expected that in the future, the decision between a GIS and a spatial decision support system will become increasingly blurred. Planning support system. A parallel development in the planning field is the concept of a planning support system. A PSS, as first advocated by Harris in 1989, is a combination of computer-based methods and models that support planning functions. PSS not only serve as a decision support system to decision makers, but also provide the tools, models, and information used for planning. That is the information technologies that planners use to carry out their unique professional responsibilities. PSS comprise a whole suite of related information technologies, that is GIS, spreadsheets, models, and database that have different applications in different stages of planning. GIS are becoming important components of PSS by virtue of the geoprocessing, graphic display, database, and modeling capabilities they process. However, a PSS cannot consist of a GIS alone. It must be also include the full range of the planner's traditional tools for economic and demographic analysis, forecasting, environmental modeling, transportation planning, and land use modeling. It should also include other technologies such as expert system, decision support aid, that is multi-criteria decision analysis, hypermedia system, and group decision support systems. Trend and factors influencing the use of GIS in urban planning. The database management, mapping, and spatial analysis function of GIS have been very useful in the many areas of urban planning. The main weakness of GIS in urban planning is their linkage with urban planning models. There are different strategies for linking planning models with GIS. They range from loosely coupled to tightly coupled and fully integrated architecture. Integration based on the loosely coupled architecture involves Importing and exporting data between GIS and planning modules. Data are exported from a GIS and transferred to an external program for execution. The modeling result may be sent back to GIS for display and further analysis. Tightly coupled architecture integration involves writing programs with the GIS environment, avoiding explicit data transfer between software packages. Today, the loosely coupled architecture is the most commonly used in the integration of planning models and GIS. The California Urban Future Model used the loosely coupled approach in the integration of GIS with models. The integration of multimedia data types and the use of GIS in the intranet environment, especially the World Wide Web, that's mean WWW, are some of the recent GIS developments that have had great impacts on urban planning. The incorporation of images, videos, aerial photographs, and sound with the GIS can increase the planner's comprehension of the planning problem that they are analyzing. The integration of GIS with virtual reality can enable planner to examine the space that they are planning more realistically. Factors. The use of the GIS in urban planning does not depend solely on the development of new GIS software and hardware. Indeed, this consideration may be among the least important in influencing whether GIS is used in urban planning in a city. The status and character of the organization, data, state of the art of planning, and staff are more important factors, and this section considers their importance with particular regard to developing countries. Some factors influencing the use of GIS in urban planning is organization, data, state of the art of planning, and staffing. Organization. No matter how sophisticated and advanced it is, a decision support system is useless if it is not being used by decision makers. Studies on the application of GIS repeatedly show that staff and organizational factors are more important than technology in successful application of GIS. Data. The lack of available data remains one of the major hindrances in the usage of GIS. As a type of information system, GIS needs graphic and textual data in order to function. There is no life in GIS without application, and there can be no application if there are no data. In short, data are vital to GIS. State of the art of planning. The state of the art in planning in the developing countries has not advanced much in comparison to GIS. The skill of planners and the planning system may not be ready to utilize the data and functions provided by GIS. Planner could employ GIS in conjunction with new planning techniques so that they are better able to diagnose potential problems and assess the desirability of alternative plans. In spite of this, most planners in the developing countries are not yet aware of the benefit and potential application of GIS. Furthermore, even though much effort has been spent on data collection, comparatively little has been spent on transforming data into information for making planning decisions. Staffing. With the rapid growth of GIS, there is a shortage of human resource even in the developing countries. This shortage is more severe in the developing countries both in absolute number and relative terms. There are very few people who know about GIS in developing countries. The shortage of skilled personnel is currently very severe. especially given the number of cities and regions in the developing countries that can benefit from GIS. The problem of training is very severe in the developing countries because of the lack of expertise and shortage of funds. Training of GIS personnel is often carried out by software companies by either sending their staff to run short course on site or sending the operators and users to train in their headquarters. GIS courses and training program, if available in the developing countries, are normally carried out in the Department of Surveying, Remote Sensing, and Geography. There is also a general lack of GIS courses in planning schools. To use GIS more effectively in planning, planner must be trained not so much in the operation of the system, but in how to make use of the data and function of GIS in different processes of planning and plan evaluation. That's all for today. Thank you for watching this video.